Math education in this country for about 70 years has been obsessed with the idea that students need to learn how to do math problems, just really specific types of math problems. And if you can do those types of math problems, then you know math. And if you can't do those specific types of problems, you don't know math. Not a lot of focus on understanding or doing anything interesting or creative or figuring things out on your own. To that end, section 6.2 has a bunch of weird inverse trig problems that there's a very specific strategy to figure out. The strategy the book goes through is a little different. I think this one's a lot more simpler because it involves drawing and looking at it visually. Suppose, for some reason unknown to you, but maybe it's in calculus or advanced number theory, someone wants you to find the sine of the inverse tangent of 3/7. So there's a strategy for this. You think about the result of an inverse trig function as an angle. So write this inverse trig function, the inside function, as theta equals inverse tangent of 3/7. Then what you're trying to find is the sine of theta, which is equal to y/r if you're looking at some sort of unit circle with a radius r and a vertical coordinate y. Now what you're going to do to figure that out is draw this into a picture. So come down here, inverse tangent of 3/7. Rewrite this as tangent of theta equals 3/7, and we know that equals y/x. That's our definition of tangent function using a unit circle. So draw a picture. Y equals 3, x equals 7, and let's label that r. Now use the Pythagorean theorem to solve for r. R we always regard to be positive, so I've discarded the negative square root here. So now just go back up here, sine of theta equals y/r. Y we know is 3, r we know is the square root of 58. So write this as 3 over the square root of 58. And that's all there is to it. You didn't need to actually find the value of theta here. You could do the whole thing involving exact coordinates using just this triangle. Using a similar example, let's go over here. Find the cosine of the inverse sine of 5/13. So first, write this as cosine theta, where theta equals the inverse sine of 5/13, which means the sine of theta is 5/13. This is what you're trying to find. This is what picture you're going to draw, so go ahead and use this to draw a picture. Cosine theta equals x/r, so once again use the Pythagorean theorem to solve for x. I'm assuming we're in quadrant 1 here, which seems like a safe assumption since this is positive, so I discard the negative square root once again, I just get x equals 12. Now cosine theta equals x/r. That's it, that's your final answer, you are done.